You can also use trig to find angle measures. This time we don't know our angle measure, and they put a question mark, but normally somebody will put theta or x or y, just any variable in there. Then I said they just put a question mark, no big deal. And notice we have all three sides. So the good news is you can use any trig function you want, but you better identify which pieces are first. This 90 points directly at that guy, so that's my hypotenuse. Theta is trying to eat the 39, right? So that means that's opposite, and that forces this to be adjacent. So we can use any and all of the trig functions. So I'm just going to use sine, because I know all three sides, so sine is some old hippie, opposite over hypotenuse. So the sine of my angle theta is the opposite side, 39, over my hypotenuse, 65. And it's algebra time again. What's happening between the sine and the theta? Well, any two things that are jammed together are multiplying. So what's the opposite of multiplying by sine? Well, it's dividing by sine on both sides. That looks like fun, doesn't it? Take care of the easy side first. Sine divided by sine is 1, and theta is left. But then you've got this weird fraction. Mathematically speaking, when you have a fraction divided by something else, what you're supposed to do is leave the first fraction alone, change this divide to a multiply, and now right now this is sine over 1, and then you flip the second fraction to make it 1 over sine. And then using the powers here, this is sine to the first power, but if you move this up, your exponent changes to a negative. So the shortcut here is anytime you divide by a trig function, instead of having to go through all this rigmarole, just remember this sign flips up but gets an inverse, or a -1. And then your 39/65 stays the same. And we'll do a couple more of those. But now this is calculator fodder. Make sure you're in degrees. And he says this is sine to the -1 power. Well, if you look above your sine, see that in blue? So I'm going to do second sine. And you'll notice on my screen I now have inverse sine. 39 divided by 65, and then close your parentheses. Again, we're rounding to the nearest tenth. So that's 6. 6 is bigger than 5, so that 8 is going to turn into a 9. And theta is 36.9, and now it's an angle measure, so it's degrees. Probably look at that again. So right now my little theta or phi or whatever is right there. My 90 is pointing. There's my hypotenuse. Theta is trying to eat 16, so that's my opposite, forcing 63 to be adjacent. I can use any trig function I want. So this time I'm going to use tangent. Why? Because it's the smallest two numbers, but it doesn't really matter. So tangent is opposite over adjacent, tripping on acid. So I'm going to say tangent of theta equals the opposite side, 16, over the adjacent side, 63. I want to find out what theta is. That's my variable. So since this is times tangent, I must divide both sides by tangent. The tangents cancel over here, reducing to a 1. So theta equals. This is that weird triple fraction. So instead of having to go through all the math, I'm just going to remember this is inverse tangent of 16 over 63. And then it's calculator time. So again, with my inverse, you have to hit that second button, because you'll notice it's right up above. Other calculators have shift, but you'll find your way. So second tangent, you notice I have my tangent to the -1, or tangent inverse. 16 divided by 63, close your parentheses, equals. Rounding to the nearest tenth, 5 or bigger, so that 2 is going to become a 3. So theta will be 14.3 degrees, since it's an angle measure. And as I said, you can use whichever trig function you want. So I'm going to just do another one with the same triangle. Well, remember, our answer is 14.3. Let's say instead of using tangent, I wanted to use sine, which is opposite over hypotenuse. Then my sine of theta would have been 16 over 65. The opposite of multiply by sine is divide by sine. Sines cancel, leaving me theta. Triple fraction, I have to use inverse sine. 16/65. So we're going to come in, clear out our calculator. Inverse sine, second sine, 16 divided by 65 equals. Sure enough, I got the same answer. That's that 14.3. So theta would still equal 14.3 degrees. There's only one left. We've done it with tangent and got 14.3. We've done it with sine and got 14.3. So let's do cosine real quick. Cosine caught another hippie. So cosine of theta would be your adjacent side, 63, over your hypotenuse, 65. The opposite of times cosine is divide by cosine. Cosines cancel. Triple fraction, I'm going to use inverse cosine of 63 over 65. Here comes your handy-dandy calculator. Inverse cosine, 63 divided by 65. Sure enough, it's still the same answer, 14.3.